All right, let's dive right into this explainer and kick off the 13th rung of your LogicLadder Roadmap. This is a big one, guys. It marks the official beginning of Phase 2, Backend and Systems. Now, up until this point, we've been focusing pretty heavily on the fundamentals, right? How our code thinks using logic and how it remembers things using databases. But today we're going to explore how those two distinct parts actually talk to each other by building your very first API. Let's start with a quick problem-solving scenario to frame exactly why this matters. Think back to the global warehouse concept we talked about previously. Your database is basically that massive, highly secure warehouse where all your valuable information lives. So pose this question to yourself. If your data is stored safely locked away in that warehouse, how does a user on a mobile app actually go and get it? I mean, you obviously can't let every single random user just walk off the street, wander into your warehouse, and start pulling things off the shelves. That would be absolute chaos, not to mention a massive security nightmare. There literally has to be an intermediary.
And that brings us to the concept of the digital waiter, which is how we actually bridge the gap between our front end and back ends. To avoid any cognitive overload as we introduce this new backend architecture, we're going to look at the Application Programming Interface, or API, through a super relatable restaurant model. This brilliantly illustrates our whole ecosystem. So the user sitting at the table with their phone, that's the customer, or your front end. The kitchen, where all the food is securely stored and prepped, that's your database. And right in the middle, your API is your highly efficient digital waiter. It's the secure designated bridge that's actually allowed to talk to both sides. Honestly, in 2026, the absolute best engineers are the ones who know how to build efficient waiters that never ever drop a tray. Let's take a peek at the waiter's notebook, breaking down what we call HTTP methods. In web development, our digital waiters use a very specific language called HTTP methods to take down orders. Just focusing on two micro concepts for now. Notice the key distinction here. A GET request simply asks the kitchen to see what's currently available. It's the digital equivalent of a customer saying, "Hey, I'd like to see the menu, please." On the flip side, a POST request actively sends brand new information back for the kitchen to process. It's like saying, "I'd like to place a new order." Understanding this core difference between just looking at data and actively sending new data is the absolute bedrock of back-end communication. All right, enough theory. Let's get into some live coding and build your very first Express server. We're transitioning over to Node.js and Express now, and you'll see we've got a really clean, distraction-free setup going. We're using a high-contrast community material theme in VS Code, and I've intentionally bumped the font size up to extra large. Why? Well, because readability is absolutely crucial when you're learning new syntax. Plus, since a massive third of you are probably watching this explainer on your phones right now, you need to be able to comfortably read the code without squinting. Okay, looking closely at our server code, I want you to pay special attention to this exact line right here, app.get/menu. This is the precise location where our digital waiter is actively listening for that GET request. This is the literal moment the waiter is standing at the table and hears the customer say, "I'd like to see the menu." Now look slightly further down in the code, right to where we actually tell the app to listen. You'll notice the port number 3000 circled there. Now, what exactly is a port? Don't overcomplicate it. You can simply think of port 3000 as the specific table number our digital waiter is assigned to serve. If the front end doesn't send their order specifically to table 3000, our waiter is completely oblivious and just isn't going to hear it. Moving on to a little growth mindset moment, dealing with the infamous EADD-RNUSE error. As a lot of educational research emphasizes, programming isn't just about perfectly typing out syntax. It is fundamentally the act of solving problems. For instance, if you try to start your Express server in your terminal when, oops, another server is secretly already running in the background, your terminal is going to throw this exact scary-looking message at you. Error, listen, EADDR use, address already in use, C:3000. Now, when beginners see a giant wall of red text like this, panic usually sets in, but let's demystify it right now. Look at the specific code name for the error. EADDR in use, address in use. Bringing it all back to our restaurant analogy, the fix for this becomes incredibly obvious. You simply cannot have two different waiters trying to take orders at table 3000 at the exact same time. They're going to bump into each other and completely drop the tray. The address is literally already in use by the first waiter. So to fix this, you just need to find the terminal running that first server, shut it down, and clear the table so your brand new server can take over. Easy, right? So we've successfully built a basic waiter that can listen at a table and take a simple order. But
I want you to think about this question as we wrap up today's explainer. What happens if the customer makes a totally bad order, like requesting something that isn't even on the menu? Or worse, what if they maliciously try to bypass the waiter entirely to sneak right into the kitchen? Keep that in mind because it perfectly sets up our next phase on API validation and backend security. Until next time, keep building.